Give a shout out to our sponsors and partners. First one's Ryan. We have sponsors over in media. We're giving us 40% off, 50% off ebooks. So if you never buy books, go there and get money free. So same thing for Manning. Give you 36% off. So if you want a different book, go there.
Worth noting, Manning's early access program is fantastic as well. You can get books while authors are still writing them. So if you want to be slightly ahead, they're really good for that.
Yeah. Sponsors also Society Work for the place location. Check out other meetups in town. Different things going on. We got Code Creativity, which I think is coming up soon.
Yeah, it's coming week, I think. Next week.
I believe so, yeah. The Carbon Cloud Attack Guide is this Wednesday? Next Wednesday. Chad at lunch. Chadu, Chad, all these different things. WordPress channel, go check them out. You get involved with us, go to the subreddit, try to have different conversations going on there, and also try to have RC channel, which there's 28-ish people there that I every day to talk, so check that out. Multi-guests. I'm Justin. Check if you have something to say or want to give a talk, let me know. I'm going to give us up to Andrew now.
Thank you. So, I agreed to do this a long time ago, before I knew what my last about 6 weeks were going to be like. And the title I gave made more sense when I gave it than it did when I started doing the actual presentation. So, just give you a lot of background on this because it's kind of relevant, I guess. This is a project that I started I wrote about 2 years ago in about 2 weeks, actually. And I was working with a local startup, and they had my background, if you don't know this, is in manufacturing. I've been in manufacturing for basically my entire career up until pretty recently. And one of the things I've done is data acquisition and using stuff like Python and other non-traditional industrial tools to do that. So we had a startup in town who was focused on providing a platform for data acquisition and analytics for small and medium manufacturers. Their client-side app, the device, they had settled on using a Raspberry Pi, which is not really reliable enough for industrial use, but it worked okay if it has lots and lots of watchdog scripts. So basically, we had a specific use case where we had a device that was moderately reliable, a place where the internet connection was not very reliable typically because a Raspberry Pi with wireless is very unreliable. Raspberry Pi with Ethernet is not the most reliable just because of the Ethernet over USB and all that. So we wanted to be able to recover from pretty much any kind of screw up and still keep our data. So they were using a Node app to do the data collection, and it was kind of custom written for one particular sensor that they had. And when they started to try to untangle that and use it with other sensors, because of course each industrial customer had a different set of devices to interface with, it started getting hairy. And I think it may have been the first Node app they had written, so that showed strongly. So I started working on it, and quickly, considering the simplicity of what we were doing, decided that Node was probably not the best thing to do it with at the time. In reality, the use case is probably a really great Node use case because it is async, input and output. You're collecting data and sending it to a server. But at the time, and considering how bad that code base was and my experience with Node at the time, I decided to go with Python. So I set out and just kind of wrote the whole thing on my own at night over a course of about a week and a half, I guess. And the basic job of this app is to collect data from a device, whatever that device is, and push it to a queue locally so that if the internet connection is not there, the data still just backs up in the queue. When the internet connection returns, it dumps the queue. That's this. So SensaPi is what I named it when I decided to try to open source it about a year ago was when I started this project. Because the startup kind of went defunct and I had this code base sitting there and I wrote it, it was my code, and I thought it was valuable and it would be useful for other people, which might be true. We'll see. This was probably a bad idea. The bad idea model that I landed on when I was determining to do this was that each node, each device, whether that device represented one piece of equipment at a customer site or an entire customer site, would be associated with a chunk of config, JSON config stored on the server. That config would be universal, so the server would use that. It would have all the metadata for displaying and doing analytics on that metric, and it would also be used at the device side. So you really only had to manage one state of config for the entire app. This made it very easy for basically each node got a UUID. It would call the server and say, hey, here I am, give me my config, and it would tell it what to do. So each metric, so a given node could have many metrics, things it was collecting from its environment, had its own config node with the UUID, what piece of software to use to collect the data for that particular metric, relevant metadata. This is stuff that was mostly used server side for displaying, such as scaling factor or units on the raw return data. So to chase this bad idea, I found two pieces of software that worked really well, pretty simple, and they solve these problems really well. So AP Scheduler is a cross-platform replacement for cron, but does intervals a little better than cron does. So if you ever need to make sure that you're running things at certain times or every so much time, it's a great package. Works on Windows, Linux, Mac. And the way it works is kind of interesting. So I could actually instantiate these modules that were pulling data into the object, and it would just into the job, and the job would just run. RQ is a really simple library for queuing jobs using Redis. It's kind of neat because there's two ways to use it, and I used it the kind of dumb way, but really simple if you just need a queue, which is when you put a job on the queue, it puts the entire Python object that you're going to call. And when it gets a chance to run, it just pulls the code out of Redis and runs the code that was in Redis. What this does is you never have to write your own workers. Basically, the worker just runs the thread underneath the main worker. Not very efficient. Would have been better with its own worker on the Raspberry Pi, but worked okay. There were no performance constraints there. But again, I wrote this in like a week and a half of nights. The data source modules that I wrote initially, well, partially initially, partially afterward, but so sysstats, which had a different name, but again, untamed. This was just to get data from that local collector node. CPU, load averages, memory usage. On the Raspberry Pi, we needed to monitor temperature because that's a problem in industrial control cabinets where temperatures get pretty high. The Raspberry Pi could get pretty hot. And then the beauty of this was that you could, have this whole common architecture and write a very small amount of code to interface with proprietary devices. And so the first device I did that with was this Omron E5AK, which is an industrial process controller. And it uses a proprietary RS-485 serial protocol, which is unfortunately common on industrial stuff. The proprietary side of that, RS-485 is a great technology. Don't scoff at RS-485. RS-485 is kind of a precursor to Ethernet in that it used balanced signals, so it's very immune to noise. which makes it really excellent. And because it's running at slow speeds rather than having the 100-meter limit we have with Ethernet, it's like, depending on the, it's actually scales with the speed you run it at. You can run it like a mile. You can run a single pair of twisted wire and have communication a mile away. So it gets used in industrial applications a lot because of noise immunity. And you just don't need that much bandwidth. So anyway, so that was the first one I did. And so the module that collects data from the Omron has in it the requirement for Pi serial, so that only if you're connecting to something with that requirement does the Pi serial module ever load. You don't actually have to load it by default. The next one down, the one wire, the DSB or DS18B20, which Sean knows well now, is a really common tiny, it looks like a transistor, a BJT transistor, but it's actually a digital temperature sensor. And it uses the one-wire protocol, which is really fascinating protocol. It doesn't have the length capabilities of RS-45 because it's not balanced. Indeed, it doesn't really. I mean, it has one reference, so it actually gets power for the device from. Well, depends. The DS18B20s have a bus power, but they only need one communications line. So they have a ground, 5-volt power, and one communications wire, which is pretty crazy. And they do some really clever stuff to work. The other neat thing about them is that one communications line doesn't just go to one sensor, it's a bus. So you can put, is it 128 the maximum? So you can throw 128 sensors on a single 3-wire line. Yeah. One of the neat things I did with that was very carefully take Cat5 cable and kind of embed these down the length of a cable. So you could just pull the cable out across a room and you'd get, the 10 or 20 temperature zones off the one cable. Anyway, so it's it's not real common in industrial applications, but it's very common in stuff like coffee pots and random crap like that in consumer electronics. So it's very cheap. They're $1 a piece essentially. So it's a really good way. The only thing is for industrial applications, they can't do, high or low temperatures. So human survivable environmental data is what I said there. So that's basically the limitations of it. And then later, while the original code base was still working, but well after I wrote it, before I attempted this refactor, I acquired an Omega, which Omega is a large supplier of industrial sensors. They've been around for years. They make all kinds of crap, or they don't make it, they market it. One of the two. So they had a temperature sensor that is easily 20 years old at this point that had a 10 megabit Ethernet connection. And documentation was nearly nil, and the way you interfaced with it was through a embedded Java applet, which only worked in really old computers because of all the security issues. So you have to completely disable all Java security in order to run it. I think what I ended up doing was spinning up a Windows XP VM and running their Java applet, and then watching the communications with Wireshark and kind of extracting the raw TCP socket activity to determine how to communicate with it, because there was no documentation. But again, I was able to very quickly write this module that just collected data from the Omega. I didn't have to worry about anything else because the core app was doing something with the data. Here's a little bit better defined. The architecture, each node consumes its config, and then as it starts, loads the required source drivers was the original term I started using. I don't like that, but modules, sources. So only if in its config node it says it needs to access a serial device, will it load the serial module. The thing I tried to add in this refactor that hasn't been finished yet, unfortunately, again, because I just ran out of time, was rather than having a proprietary, because when I wrote this, I wrote it for a proprietary server architecture that it was sending data to. I decided, well, I'm having to fix that anyway. I'd rather have that be configurable as well. So the goal is to have sender modules. So, right now during development, because I haven't got to the point of wanting to push it to a server yet, one of those is probably going to be Graphite, if anybody's familiar with metrics and monitoring in IT infrastructure. Graphite's very common, and it's Python. Right now I'm using a command line sender. So like when it pushes data, it just dumps on the command line.
Is it set up to be like on a plugin API? So
Yeah.
write like a log stash plugin?
Exactly. That's the whole point. So yeah, and sometimes you might want to send data to Logstash, and you might want to extract something from it and send that to Graphite. So being able to do both of those is kind of interesting. And again, the goal is to have something a little simpler, because obviously you can run Logstash, you can run Graphite, you can run, what's the one that goes in between them that I use it, but it's Node. StatsD, yeah. So StatsD will, pull Logstash and push the time value metrics into Graphite, et cetera. So if you throw that at even someone who's interested in this stuff that's coming from the industrial background, it's just too much for them. So the goal is to make something fairly simple, but robust. And so then once it determines what all metrics it's responsible for and all the sources are instantiated, each metric can have its own time interval. So you can have something pulled every 5 seconds, something else pulled every 10 seconds, et cetera. It'll calculate what the greatest common interval that it can run, and then set up a job that will run every greatest common interval. So, if you've got all your metrics are every 10 seconds, but one's every 5 seconds, well, it's going to run the job every 5 seconds, but it's going to ignore all the metrics that are every 10 seconds, every other job, basically. So some stuff we didn't really care about, but once a minute. Other stuff we wanted every 5 or 10 seconds. That's how that worked. And then it would set up the sender queue using RQ, and then finally start the job scheduler. A job would retrieve data through the module that was instantiated, put data in the queue, and then repeat until all time intervals that intersect with the job that it's on are handled, and then exit, and then the next job tick would fire after the interval. All right, so like I said, I spent a lot of time trying to make this work. I got one module working. I need to show that to you, the sysstats module, and then answer questions. So any questions so far? So what? So God, mine's big too. Like, it's already huge. Stop it, Kyle Gordy. Anytime. How do I make this bigger? Apparently, it doesn't work in here for whatever reason. I mean, yeah. I think this is just you're gonna have to deal with this, Kyle. Sorry. Yeah. So each source there's a base class which should probably not be named base class, but again, this is all. But there's a base class that inherits certain common functions, like getting a timestamp in the correct format and that sort of thing in it, which sets up the data and the feed data from the config chunk that's handed to it by the core app. The way I've done this so far, and I don't know how, like, this is where I got to today, where I was like, crap, I could get more done, but I'm not sure if I'm really going in the right direction. But anyway, there are the abstraction of things to do to get data, like in this case, sysstat. to get load averages, it's one command. You get all 3 load averages, but that's 3 separate metrics. So I have this concept of a type of data, which so far has pretty well mapped to one action to retrieve all of the metrics below that type in the tree. And so like get mem info, that's one command. This VM that I'm running this in spits out a crap ton of data at you if you ask about memory usage. So I really care about, I think, 3 or 4 different metrics in the memory usage, at least for the Raspberry Pi when I originally wrote this. So what this does is it currently detects if in the config a given type exists, and it will only run, when you run get data, it'll run, it checks to make sure that your timestamp has expired. In other words, if you sat there and you had 2 jobs that followed right behind each other, and you had a minimum time on this because you don't want to just like hammer. The minimum time that a given metric can run to get data is separate from necessarily the amount of time, just to prevent it from hammering a little bit. So it checks that first, make sure that, or if you collected data using a different, and I think I may have cleaned this up and got it out of there because of the way it was doing things and the way it's doing things now. I may not need it anymore. But anyway, at one time it was getting all the types, so it would run all the commands to update the data, and so it would only do that. You know, if you had a job and there were 4 things, 4 different types, you didn't need to continually do that for that one job tick. It would wait until the next job tick to call data again. Anyway, and it just returns the result as a float times the multiplier that was stored in the config. And so what? It is. Watch this.
The magic of technology. Fourth push. Not even once. That's fine. Everybody knows what I'm thinking, right?
If you, that raspy mon file, that Raspberry Pi monitor is what this used to be, but obviously I'm running on a VM, so it's just Linux system stats, so it didn't make a whole lot of sense to call it Raspberry Pi monitor anymore. Even though it would still work fine on a Raspberry Pi, it just was too specific. Did I get all these? Yes.
Make sure to add everything.
Well, I don't know that I have my ignore set up quite correct to ignore for the new Pi V and V, because this is all, I moved 2 to 3 when I was doing this too. So the original project was all Python 2.7. This is all 3.43. So, and I've got just some messy files in here that, again, I just don't have in my git ignore. Oh. Interesting. Because, you know, live coding, if it can fail, it will. Ugh. There we go. All right. Now you should see it in GitHub. And so this test, I'll show you this test.py here. I also wrote it completely without any testing the first time because you only live once, YOLO. So I started writing some tests for this as I kind of refactor. So this is just testing one module. So it's not testing the entire scheduler because that's still kind of broken right now. But to test a module, we give it a name that we're getting, the config and test, which means that basically everything above it you don't need. So we're just going to give you the individual, and we're calling each method directly instead of through its normal interface. So we can give it its chunk of config just for that method in line. So what?
Is it array unit testing?
Yeah. So because I'm doing this on a live server, and I'm checking sysstats, I can't really check for exact values because they change, but I can at least check the type and make sure it's returning the right type. Plus this, if I throw a print in here and run the test, throw a print somewhere in the code and run the test, it kicks out output that makes sense and shows exceptions. So you can see here, this is the amount of well, you can't really see this projector. Did you focus too? Because it's like, it's really hard to see. I'm sorry. So the source, yeah, it's as good as it gets. The source is kind of the root of a metric, and so that config is all the config needed for one metric. And you can. So what? Probably.
Plus, you can scale the text.
Yeah. Maybe. Yeah, the change, this change set is pretty, yeah. I don't know why my internet went to like extra slow. Oh, really?
GitHub was having connectivity problems earlier. Our continuous deployment server was having issues pulling things.
Oh, well, that would explain. Well, yeah, because that other command that was failing was from DigitalOcean to GitHub, so that's nothing to do with here.
Server was having communications problems with GitHub all day.
Yeah.
I imagine that someone's trying to restore from here.
That could be another hack.
Yep.
Well, maybe that wasn't such a good idea.
Yeah, this will work right now.
Not such a well executed idea. So anyway, in this case, type again denotes the actual kind of command that's implemented in that particular module to get that particular piece of data. I'm not really sure. It's probably not best to store it this way. It's probably best to have like a somewhere in that module where it looks up for a given type of parameter, which command to run to get it. But again, that's all stuff that we all learn things, and it's been 2 years. And then param is the exact value that makes up that particular source. The thing you don't see here is a unique ID, which would get applied just a little bit further upstream. So anyway, here we go. So this is where we kind of set up everything that's common. This is all the commands that actually touch something physical or get data from somewhere are just lowercase get and then camel case the particular metric, or sorry, the type. So right now I'm doing some stuff to call those dynamically, which may or may not end up surviving. We'll see. But anyway, evolution of a project. failure of a presentation. I mean, lots of things demonstrated here tonight, I think. Anyway.
Is the long-term vision for this essentially to have a collector that just has a pluggable sender and receiver module on either side of it?
In Python versus all the other ones, which there are some that are set up that work pretty well for IT infrastructure, but the idea is rather than having to have another Python project, kind of two things. One, have a common, because you can end up, if this is open source, people can contribute modules or drivers or whatever you want to call them. And then there's like a common pool of readily available Python code to interface with X number of sensors or physical interfaces. This is something I've done a lot of, is developing these, the driver, the interface between a conventional piece of compute hardware and some specialized proprietary thing that the vendor won't talk to you for less than a lot of money. So this was kind of to make my job easier, even though I haven't really used it because I've been doing other things. But yeah, I mean, that's the goal, is to completely pluggable, send and receive, which again makes a lot of sense for Node, kind of, just because of the async aspect, but it's a little easier for me, especially with serial communications in Python, than Node. You can't get async in serial, like. So.
Before the concept of asynchronous I/O existed, so.
Yeah, kind of. Anyway.
Before
So,
we cared, rather.
yeah. Any questions?
What about analytics to analyze data?
So, I mean, that's all about what you push the data to, right? So Graphite, which is something I'm very familiar with, is great for real-time kind of reporting and visualization and that sort of thing. Deeper analytics, there's another project I started, but again, because I haven't been working in this field much lately, I've been working at kind of a higher level, not at the implementation level. It's because one of the things that's lacking in most of these projects for IT is real-time analytics and alerting that works well and is easily configurable. There are Nagios is a common one for IT systems, and everybody hates it, but nobody hates it enough to put the work in to write something better. And there's a few, there's one that's really promising, that I got really excited about, but I haven't really got to play with much. And I think it was the ChaDev lunch talk that got canceled for Snow. We were going to have a developer from Mozilla talk to us about their project, Heka, H-E-K-A. And Heka is designed basically to do what this does, but in Go. And of course, it's not focused on industrial applications, it's focused on conventional IT. But the nice thing about it is it's the full stack. So it has a storage engine, it has collectors, it has real-time streaming analytics, all of that. Still modular in that, different processes and workers and all that, but in a monolithic code base that you don't have to like figure out how to interface all. Because right now, to put together an enterprise monitoring stack with open source components, everybody does it, but everybody has a team of people that do it. It's not plug and play by any means. Graphite, I mean, to configure the latest version of Graphite, there aren't actual instructions on the internet. I mean, which would blow your mind and seems crazy, but it's just how it is. So they're kind of back-end people working on this stuff, and they're very tight community. I go to a conference every year. I say every year. I've been once. I'm going this year, so that's 2 years. Monitorama in Portland. It's great. It's all these guys that do this stuff, but it's out in the weeds. I mean, they're very much the guys solving hard problems for IT. So, any other questions?
So should we like to build a Nagios sender out of this? Because then it slots in industrial settings into IT staffs that already have that expertise and Nagios' primary interface is a Python data collector. So I think
Yeah.
it'd be interesting to try and expand this into fitting both sides of the world.
Yeah, you could definitely push. I mean, you could push data anywhere. Nagios definitely. Yeah, for sure. I don't think that. I mean, I don't even think that would be really hard. Nagios is a pretty. There's a lot of things that push to
I
Nagios.
mean, they've got a uniform sort of collector schema that you send back through, so it should be pretty straightforward to build senders and receivers on both sides.
I think. So for my personal IT stuff, I use for a sender, I use CollectD, just because it has a fairly efficient binary schema for sending data. So, but I think that was another one of the things that Heka did really well, was efficiently moving data around. Graphite is great, but it's great because it's simple, but it's also, its weaknesses are because it's simple. So it pushes basically just text strings around. That's how all of its data is pushed. And so it's great. It's really easy to write anything into Graphite, like anything, but like even just securing it to take data into Graphite from a remote source is kind of a pain in the butt, because there's not a good way to secure it very well. It's just an open TCP socket. So it's designed to work on trusted networks versus something like this.
If you're in that space and you're interested, I would check out Logstash. They finally came up with basically you can put together a TLS trust chain between two machines to secure that pipe.
Right. And
that's the closest answer I've seen to security.
Well, CollectD, that's the other thing CollectD does is, and then with Logstash, when I'm doing logs, our syslog will do the same thing. So I use yeah, instead of running a dedicated agent on each machine for Logstash, I just run our syslog and push all the parsing to a central server. So
that's how we just moved over as well. But Kibana on top of that. So.
Yeah, that's really what I wanted this for, was to push data into Graphite, and then running not Kibana, but the Kibana for Graphite versus. I can say Torkel Odegaard is the guy that writes it. That's sad, but I can't remember the name of the project. Anyway, yeah, so it's great. I use it. Crap, what is it called? Anyway.
Yeah, Grafana.
Grafana, yeah. That's right. Yeah.
Yeah, do the same thing, staring at like logging monitoring structures for the last few weeks. So.
Were you asking something, Joe? A minute ago?
So, I guess it's looking for something like wheelhouse, this kind of stuff you're talking about. So, when you say you have this on the IT side, what kind of things would you want monitoring in IT?
Everything. So, you care about all of it if you're doing IT well. So everything from switch packet counters, Logstash. What Logstash does is this. There's two types of data you typically handle. One is log entries and processing them and making them parsable and searchable. Kind of harder, but at the same time not. It's really weird because the data that comes out that's just time series data, like, packet rates on Apache or something, like how many requests you're serving and that over time.
When you say sensor, I'm thinking hardware.
Right. So when I talk about conventional IT systems, it's all software related. They do a little bit of hardware monitoring, but it's typically through some terrible, janky vendor-written plugin for Nagios or something, and
monitoring UPS for 500.
Yeah, and
You're talking about standing up Python processes in a different Linux kernel.
this,
Monitor, yeah, well, in IT, you say you put some kind of monitoring in the Linux kernel, have it watch something like
sure, yeah,
network traffic or
yeah,
logs or something like that.
and generally,
This looks like more like a hardware piece where I have hardware sensors.
right, yeah, this is designed it's to run on x86 architecture, but to interface with various hardware platforms outside of it. Or I say x86, not x86, but Linux, anywhere Linux will run, which is, in this case, it was actually designed for ARM, so totally not true. But yeah, that's kind of the difference. So IT, most IT equipment ends up having SNMP. That's how they go. So even the UPSs will have SNMP typically, and it works. But for me, it's just a nightmare to configure. So I actually prefer some of the simpler protocols just because it's easier to get the data. And if you're asking for the data, you know what it is anyway. You know what to do with it. You don't need all that metadata that SNMP gives you or doesn't really give you, just has in the definitions. SNMP is a protocol written for computers. That's what that boils down to, not for humans, which is not great. So, all right.
Question, Cash, Sean, question?
I don't know. Sean, can he ask you a question or are you still mad at him?
It's related. He said that you use those temperature sensors that you was talking about. Just curious what you're doing.
I just want to collect data. Like, I want to move around the floor and collect the data around the. It's really different between being aware you are in space.
Yeah.
Like in outer space, where we work, is significantly different from the mid space and the side. So I want to measure like, so what's the fluctuation between the two sides?
That way you know how hot.
Yeah.
And
for the Raspberry Pi, the kernel driver is really there's a caveat there. They changed something with that driver pretty recently. So I fought it for a day until I figured out I had to run an update for the work. So just FYI, render things.
yeah, and just to show you how easy that is, you literally write to when you plug the one wire up and you start and you plug the kernel module into the kernel. And I didn't get to the point where I was dynamically doing that. Unfortunately, the Raspberry Pi had to be configured with the kernel module in it. That would be kind of fun, actually. Yeah. So when you do that and it's connected and it sees it, it instantiates a file system with the UUID of each of those sensors as a folder. And then in that folder, there are various files that you can do stuff to. So in this case,
It sounds like the problem file system.
yeah, it is. So
Yeah.
and so you well, you have to trigger it, right? You have to write something to it.
I don't remember you actually having to do that. I just remember reading it. Like you would basically hook it up to the Pi and then you would.
You're right. I'm not writing anything here. Yeah, so yeah, you're just reading the file, and then it's got a checksum that it puts out, so you can kind of check to see if it's correct or not, if it got muddled. But yeah, it just instantiates the entire bus and gives you the IDs for the whole bus, all the devices in the whole bus. Interesting thing is, at the library, their HVAC system is so old that you couldn't get that data any other way than to put in new sensors, because their HVAC system is actually controlled by pneumatic pressure versus really like true any sort of pneumatic control systems are surprisingly still common. All right, you can turn this mic off so that I'm not rambling anymore.